I guess it's clear by now that we are going through things one by one and not necessarily getting into a lot of details in this kind of introductory course. For example, when we saw this figure of a healthy coral and a bleached coral, we are looking at it because warmer temperatures and acidification, sea level rise, etc., affect corals, which typically the warm water corals live near the surface. They need the calcium carbonate to form their skeleton, and then they support a lot of symbiotic algae that give them colors, and there is a recycling system. Corals are like the tropical rainforest, so they actually happen in a region of the ocean where nutrients needed for photosynthesis are not that high, but there is symbiosis because the photosynthesizers can take up CO2 and give oxygen, and the corals can give them a place to stay, and fish come in, they eat things, they produce nutrients through various fecal pellets and detritus and so on and so forth. So when they bleach, the symbiotic algae dies, so you get the coral polyp color of white. So we're not going into those kinds of details, and the same with these other impacts we will look at very briefly, just to give you a range of impacts that climate change has and what the projections are. And anytime you need details, of course, you can go and find more information. For example, I have a full course on climate change and health on my first channel. So looking at that briefly here, climate change increases our vulnerability to health impacts in many ways. So the factors include demographic, so population increase, change, movements. Climate change is forcing a lot of people to move, for example, in which case your vulnerability changes. Geographic factors, changes in heat waves, extreme events, sea level rise, harmful algal blooms, pathogens, viruses, biological factors and health status, socio-political conditions, and socio-economic factors. They are broad general terms, but climate change is impacting each of those things now. So climate migration is a real thing that's already happening, and you're superposing on top things like the pandemic. Extreme weather events, so exposure pathways include extreme weather events, heat stress, air quality, so pollution, global warming, and air quality and health are now one big mess. Water quality and quantity, so again, changes in temperature typically favor increased microbial growth, and human activity like food production affect water quality as well, and quantity. So if there are extreme events in rainfall, that's going to affect the physical and economic access to water quantity. So access, quantity, and quality are always something to be considered. Food security and safety, vector distribution and ecology. So when rainfall, vegetation changes happen, urbanization happens, people living in conditions like slums are also more exposed to these kind of vector population distribution and ecological changes. And health system capacity and resilience itself is going to be affected by climate change in terms of leadership and governance, health workforce, health information systems, essential medical products and technologies, service delivery and financing. So climate is often not the proximal cause, it's not the immediate cause, but it can be the ultimate cause by creating these multiple stressors that are going to just lead to catastrophic changes, like the war in Syria, for example, started with an extended drought, and then internal discontent with food availability, food price rise began as Arab Spring and then spread and then got complicated with geopolitics and so on. Climate sensitive health risks include injury, mortality from extreme weather events, health related illnesses, respiratory illnesses, waterborne diseases, and other waste related health, water related health impacted zoonosis, where pathogens are traveling from animals to humans. Vector-borne diseases, dengue, chikungunya, Lyme disease, that's a vector, that's deer tick. So as warming happens, vector populations like mosquitoes are traveling further north and further up in altitude because frost line is moving up as well. Malnutrition and foodborne diseases, non-communicable diseases as well because of people movements, mental and psychosocial health. So climate change is now responsible for serious anxiety among many, especially the young. It's not direct climate change impact, but also the messages about climate change and how dire it's going to get. People feel helpless and anxious. Health systems and facilities outcome, impacts on healthcare facilities, effects on health systems. You can say the advances in technology are improving some of the things, but there are also lots of negative impacts in terms of access. So risk can be looked at hazard times vulnerability times exposure. So hazards are increasing under climate change, which is affecting vulnerability as well as exposure. Okay, so the ocean itself, this is a nice infographics from a special report from IPCC. Triple threat to the oceans. So CO2 is increasing. Additional energy, 90% is going into the ocean. Ocean takes up 25% of the CO2. So it's getting warmer. It's deoxygenating, which affects marine life, ecosystem. Its pH is reducing, so it's getting more acidic. Sea level is rising. Sea level rise is in fact accelerating, as we already said. Flooding of coastal communities and drowning of wetland habitats. Bleaching, so we already looked at coral bleaching. Toxic algae, so warmer temperatures and increased runoff from land because of extreme events tend to favor certain harmful toxic algae. Habitats are going to be are being already affected directly because of climate change effects plus human activities as well, like urbanization, coastal population increases, other offshore activities. So lower oxygen levels are suffocating some marine animals and shrinking their habitats. Acidification, we already mentioned, affecting corals, clams, oysters, and other shell-building organisms like coccolithophores, affecting carbon export as well. Disruptions in fisheries affect marine food web, local livelihoods, and global food security as well. Climate change also affects marine ecosystems through abiotic factors like temperature, carbon dioxide, precipitation, and UV radiation. So aquatic influences include salinity stress, hypoxia, acidification, calcification, coral bleaching, water mixing and circulation, fisheries yield, and sea ice. And terrestrial systems with drought stress, tomatal function that we talked about, phenology, crop yield, food quality, fires, food quality, so it's the nutrition in the grains that you may be growing, soil erosion, glaciers, air quality effects, and you have intersections through migration, thermal stress, photodegradation, UV sunscreens, photosynthesis affected, species interactions, community composition, and species extinctions as well. Altogether, you are affecting flooding, runoff, eutrophication, which is increase in nutrients leading to harmful algal blooms, and hypoxia and anoxia. When you have a lot of nutrients coming into the coastal waters, for example, there is big blooms of phytoplankton. The zooplankton don't grow fast enough to consume them, so the phytoplankton die and sink, and then aerobic bacteria consume that and use up all the oxygen, creating hypoxia and anoxia and killing, causing fish kills, and so on. Stream flows, dissolved organic materials, dissolved organic matter, sea level rise, carbon and water cycles. This is another infographics from Foodware 365 on impact of climate change on the food industry. So ozone increase, temperature increase, precipitation, extreme events, storms, they're all affecting the food production itself. Crops and agriculture are susceptible to temperature changes. So even if Precipitation increases, temperature increase may damage crops, for example. Precipitation should be favorable most of the times, but not always. Crop growth lacking nutrients, so rainfall and irrigation heavily influence crop growth. Radiation damage to biolife, so ultraviolet radiation damaging to both plants and livestock. Bread and bakery with less nutrition. Pests impact on agriculture. So with warming temperatures, reduced frost-free days, reduced frost days, increasing nighttime temperatures, they all affect insects, pests, weeds, crops. So bee colonies are decreasing, crop yields are devastated, hurting seafood population. Environmental effect on meat, feeding people has become a climate consequence, and decimating forests for sugar. So palm oil, sugarcane, and all these cash crops are beginning to affect deforestation fairly significantly, in addition to coastal population increases, urbanization, land degradation, and so on and so forth. Okay, so we'll come back and look at the concept of tipping points, which I mentioned earlier on. There are thresholds and tipping points and switches in the system where if you keep pushing them, and then they will tip over, like a transition from tundra to boreal forests, or from narwhals to killer whales. And there are many such examples even in the physical climate system, like the Atlantic meridional overturning circulation that we talked about, or the Greenland glacier collapse, or the Amazonian forest collapse, and so on. These are real threats, not always easy to predict and not always easy to say how close they are, but if you put together all the evidences of warming, extreme events, and conflicts and so on, one can make intelligent conjectures about if they are getting closer with all these changes happening together. Okay, so we'll look at some of that in the next podcast.